Hello everyone. This is the first TA session of the course Design of Reinforced Concrete Structures, week 0. Uh, Let me start by introducing myself. I am Varsha. I'm a research scholar in the Department of Civil Engineering in the University of Science, Bangalore. Uh, so uh, I'll begin by uh, discussing a few questions. These are very basic and simple questions. It's like a pre-requirement before you study the course design of reinforced concrete structures. So we'll start. First question is maximum bending moment occurs for a simply supported beam under UDL at which place? Is it support mid span, 1 by 4th of span, or 3 by 4th of span? Uh, Here we can see a beam of length L which has a uniformly distributed load of W per unit length, like the total load will be W times L. So the support reaction will be WL by 2 and WL by 2. And at each point we can find the bending moment by WL by 2 times X minus W into X into X by 2. So this will be the bend moment diagram of this beam, which is subjected to uniformly distributed load. We can see that at the mid span, where x is L by 2, there is maximum bending moment, which is equal to WL square by 8. We all know how to draw a wind moment diagram, shear force diagram, etc. etc. I need not explain it further. So the maximum bending moment occurs for a simply supported beam at the midspan. Option B is the right answer. Going to question number 2. This is also a very similar question. Where does the maximum shear force occurs for a simply supported beam under UDL? In order to find where does the maximum shear force occurs, we need to draw the shear force diagram. So this is a shear force diagram because at the support we have WL by 2 which goes on decreasing, and at the midpoint we'll have zero shear force, and again it goes on increasing to reach WL by 2, that is the maximum shear force at the supports. So for a simply supported beam under UDL we have maximum shear force at the supports. So the answer is option A, support. From the figure, we can identify that actually shear force is nothing but F is nothing but dm by dx. That is, if shear force, if bending moment is a parabola, shear force is going to be a straight line. If bending moment is cubic, shear force is going to be parabolic. Like it will be 1 degree smaller. Shear force is going to be 1 degree. Shear force diagram is going to be 1 degree smaller to the bending moment diagram. We'll move to the next question. Question number 3. A relation between bending moment M, bending stress F, and section modulus Z. So this is a very famous bending equation, which is M by I is equal to F by Y is equal to E by R, where M is moment due to resistance, I is the moment of inertia of the section about the neutral axis, E is Young's modulus, R is the radius of curvature of the neutral axis, F is the bending stress, and Y is the distance from the neutral axis to the extreme fiber of the cross section. So from here we can take down m by I is equal to f by y. So m will be equal to f is equal to m y by I, which is m divided by I by y, which is nothing but m by z. So the correct option is option B, f equal to m by z. We'll move to the next question, that is question number 4. Under a transverse download load on a simply supported beam, the tension will be at, is it above neutral axis, below neutral axis, cannot specify, or all throughout the section. We'll see what happens when a simply supported beam is acted upon by a transverse download load. So this is a simply supported beam and a transverse downward load acts at the center. we can see that in this case the beam has a sagging action. The beam sags, in which below the neutral axis the fibers will experience tension, and above the neutral axis the fibers will experience compression. So the question is, where will it experience tension? So below the neutral axis it experiences tension, and above the neutral axis it experiences compression. So the correct answer is option B, below the neutral axis. Similarly, it's a kind of same question, that is, under transverse downward load on a cantilever beam, the tension will be at where? So we'll see. This is a cantilever beam and it is acted upon by a transverse load. We can see here that the beam experiences a sagging. The beam experiences a hogging action. That is at the top. That is below the neutral axis, the fibers will experience compression, and above neutral axis, the fibers will experience tension. So, for a cantilever beam, tension will be above the neutral axis, and for a simply supported beam, it will be below the neutral axis, simply because of the deflected shape, or simply because of the deflected shape of the corresponding beam. Now we'll move on to the next question, that is, the reinforcement in RCC takes tensile stress, compressive stress, shear stress, and torsional stress. Uh, we need to find which is the correct answer. We know that the concrete is in general very strong in compression, and it is not that concrete is not strong in concrete cannot take tensile stress, but the tensile strength of concrete is only around approximately 1 by 10th of that of compressive strength. So we say that concrete is strong in compression and weak in tension. Uh, so in that case, in order to increase the strength of this concrete, we reinforce it with steel rods so that they can carry tension. Steel is good in both taking compression and tension. So answer is option A, tensile stress. Reinforcement in RCC takes tensile stress. Now we'll move on to question number 7, that is, the minimum compressive strength of 53 grade OPC cement is. OPC is nothing but ordinary pozzolana cement. So the minimum compressive strength of a 53 grade OPC cement will be 53 NPA, that is 53 Newton per mm square. We'll see uh, that as per code, like we can find this in code, that the minimum compressive strength, 28 days compressive strength of a 53 grade OPC cement should be 53 Newton per mm square, or 53 MPa. A correct answer is option B, 53 Newton per mm square. Next question. Concrete is graded on the basis of what? Tensile stress, compressive stress, shear stress, or torsional stress. This is a picture of a figure or table taken from IS 456 table 2. Uh, Here we can see that the different grade destination of concrete, if it is M10, M15, M20, or till M80, it is given based on the specified characteristic compressive strength of 150 mm cube at 28 days at 28 days in Newton per mm square. So, the grade designation of concrete is given based on its compressive stress. So concrete is graded based on compressive stress. Again, from the same table, we can find answer to the next question. Next question is, the dimension of a cube cast for finding the strength of concrete is, it is 150 mm. That is given in the code. Like here, you can see in the notes that in the definition of concrete mix, M referred to mix, and the number to the specified compressive strength of 150 mm size tube at 28 days expressed in Newton per mm square. So the correct answer is option B, 150 mm. Now we'll move on to the last question, that is one bag of cement weighs. This is a general question, a GK question. We all see a cement bag. So correct answer is option D, 50 kg. In India, an average net mass of cement bag is 50 kg. It is given in IS code 1481/1991. So that's it. We have discussed 10 questions as a prerequisite for this course. Thank you. We'll see another for the next year session. Thank you.